In this video, we will discuss how to use average rate of change to approximate instantaneous rates of change. Anytime you see a photograph, it may seem like you are witnessing a fixed moment in time. In reality, however, the shutter of the camera was open for some amount of time. An object moving quickly enough will appear blurry in a picture if you look close enough. For example, here's a photo of a billiards table, taken with a relatively long exposure. It's easy to see here that the moment in time captured by the photo is actually an interval of time. If we can determine how far an object moved during the time that the shutter was open, we can determine the average speed of the object during that time. And if the shutter is open for a very short amount of time, then that average speed, or average rate of change, is a good approximation for the instantaneous rate of change when the picture was taken. Let's see if we can figure out how fast the ball was traveling the moment the picture was taken. We'll start by zooming in on the baseball. The blur in the ball is 3.432 inches. The diameter of a baseball is 2.86 inches. For this picture, the camera shutter was open for 1/2000th of a second. Now we know that the average speed of a baseball is equal to the change in the position of the baseball divided by the change in time. We know that the change in time is 1/2000th of a second. When the shutter was open, the ball started back here. So at the beginning of the time interval, the leading edge of the ball was right around here. Then while the shutter was open, the ball traveled over here. So to figure out its change in position, we would subtract the length of the blur minus the diameter of the ball to get 0.572 inches. And this is equal to 1,144 inches per second, which is the same as 65 miles per hour. And while this isn't actually the instantaneous speed of the ball, because it was taken over an interval of time, this average speed is a good approximation of the instantaneous speed.